Hello and welcome to this course. In this course, you'll learn about what cloud computing is, how it works, and how you can use Amazon Web Services to launch your applications in the AWS cloud. My name's Neil Davis, and I've taught AWS to hundreds of thousands of students and helped many thousands of students to successfully pass their AWS certification exams. This course is highly visual and practical. It's delivered using graphical slides, animations, and hands-on activities to give you the practical experience and knowledge of how to use the AWS cloud. The course starts right at the basics. You don't need any knowledge of AWS or even of cloud computing. We start right at the beginning, so it's completely beginner-friendly. You'll learn the building blocks of cloud computing, how it compares to traditional operating models, and you'll learn about the various service models and delivery models that are available. I'll also help you to understand complex subjects around cloud architecture in a really easy to understand way. We'll then dive into AWS, starting right at the beginning and setting up a free tier account so you can follow along with the really useful practical activities. We'll then move on to learn about the core services on AWS, including compute, storage, network, and database services. You'll even learn how to use automation on AWS, run serverless applications on the AWS cloud, and build event-driven architectures. There's a huge amount of knowledge here, and by the end of the course, you'll have developed a strong understanding of AWS and a practical skill set for using AWS services. This is the start of an exciting journey into this revolutionary technology that's changing the business landscape today. Enroll now, and I look forward to seeing you in the course.
Hello and welcome to the Introduction to Cloud Computing on AWS course. In this course, I'm going to teach you cloud computing right from the beginning. You're going to learn about the fundamentals of cloud computing, what it is, how it's constructed, and what benefits it offers to businesses around the world. And then I'm going to start teaching you about Amazon Web Services, AWS. And we're going to go right from the beginning with some very simple concepts through to some Hello and welcome to the Introduction to Cloud Computing on AWS course. In this course, I'm going to teach you cloud computing right from the beginning. You're going to learn about the fundamentals of cloud computing, what it is, how it's constructed, and what benefits it offers to businesses around the world. And then I'm going to start teaching you about Amazon Web Services, AWS. And we're going to go right from the beginning with some very simple concepts through to some fairly advanced technology with serverless and event-driven applications. So you will actually learn how to build on AWS. It's not just theory. All the way through the course, you're going to be learning how to actually implement what I'm teaching you. So I'm going to start with some simple exercises and then work through to some fairly advanced scenarios later on in the course. The best way to use this course is to simply start from the beginning and work your way through. I do use spaced repetition and I do use multiple modalities of learning, so you'll find animated visual diagrams to help you understand the concepts and visualize what we're going to build and how things integrate together. I use practical exercises to make sure that you're able to implement what you're learning. So start from the beginning, work your way through, and you'll build up your skills over time. At the end of this section, you'll find a lesson called Course Download. Make sure you follow the link to download the code that you're going to need to work through the lessons in this course. You'll also need to set up a free tier account on AWS, and I'm going to show you how to do that right in this very first section. So that's it from me for now. I hope you enjoy the course, and I'll see you in the next lesson. Hello and welcome to this lesson. In this lesson, I'm going to cover some of the fundamentals of cloud computing and what the benefits of cloud computing are. And then I'm going to go into Amazon Web Services, AWS, giving you a high-level overview of the AWS cloud and some of the features and pricing models and how we can actually manage services in AWS. I'm going to start off by comparing some of the traditional non-cloud services that you might be familiar with to their counterparts in the cloud. So for example, here we have an email server. So back in the day, and some companies still do this, but back in the day, many companies I worked with would have their own email servers. So I would often be the one setting up their email servers and you had to deploy a lot of infrastructure in different parts of the world if it was a global organization, set up all the mail. Hello and welcome to this lesson. In this lesson, I'm going to cover some of the fundamentals of cloud computing and what the benefits of cloud computing are. And then I'm going to go into Amazon Web Services, AWS, giving you a high-level overview of the AWS cloud and some of the features and pricing models and how we can actually manage services in AWS. I'm going to start off by comparing some of the traditional non-cloud services that you might be familiar with to their counterparts in the cloud. So for example, here we have an email server. So back in the day, and some companies still do this, but back in the day, many companies I worked with would have their own email servers. So I would often be the one setting up their email servers, and you had to deploy a lot of infrastructure in different parts of the world if it was a global organization, set up all the mail routing. It was quite a job. Many companies today choose instead to utilize a cloud service like Gmail or Microsoft Office 365. Then we've got file servers. Of course, many companies still use file servers today. There's lots of use cases for that, but there are counterparts in the cloud like Dropbox, for example. And of course, Gmail with G Drive, they have their own as well, as do Microsoft and many other big companies. And then we've got customer relationship management systems. These are certainly less popular on premises these days because most companies prefer to use a cloud-based service like Salesforce.com instead. Now, some of the characteristics of the cloud services are, firstly, you don't own or manage the infrastructure on which the service runs. Now that can significantly reduce the capital expenditure because this infrastructure, these servers, the networking, the storage systems, all of the different components that it takes to deliver these types of services on premises do cost a lot of money. That's a lot of capital, a lot of cash that the company might not want to give away. And then of course there's all that maintenance and management that you have to do. Also, cloud services are usually on a subscription or consumption model, again moving away from that capital expenditure, large amounts of cash, and instead spending money on a monthly basis based on either a fixed subscription rate or consumption, so actually how much you use that month. Also, services in the cloud will typically scale automatically as demand changes. So if you have a big spike in traffic, then the cloud service should scale automatically along with that demand. And of course, you'll pay appropriately for the extra services that you used. Now, there are various different types of cloud, but they all should share the same key characteristics. And I'll just cover these off very quickly. So firstly, they should be on demand and self-service. That means there should be a capability where users of the cloud, the consumers of the cloud, are able to go into some kind of self-service portal or catalog and actually choose which services they want to use. And those services should then be delivered automatically without any human intervention at all. We then have broad network access. So most cloud services will be accessible over the internet using standard protocols that we're used to, like for example, HTTP. So in some cases, you might be connected to a cloud using private networks. That's okay, either a VPN or a private connection. But at the same time, usually most of the public cloud services, all the hyperscale providers, for example, they all provide public access to their APIs. So we'll talk more about that later. Next up, you have resource pooling. All this means is that the cloud service provider have aggregated a large capacity of compute, storage, networking, all of the underlying infrastructure that is required to deliver the cloud service. And then they allow multiple tenants, in other words, the customers, to utilize that infrastructure with security isolation between them, of course. The next characteristic is rapid elasticity. So as I mentioned before, most cloud services should scale automatically based on demand. So as you get more demand for your application, the underlying infrastructure is going to scale so that your service has more resources to use. And then when you don't need those resources, they're going to be given back again. And that brings us to the last point, the measured service, because you should only be paying for what you actually use. And that, of course, means that there should be some kind of itemized bill where you can see the various different components of your bill, how much you used, what the rate for that service was, and then your total amount. So those are the key characteristics. Now you can build your own cloud, and if it has all of these characteristics, then that's what we would call a private cloud. So in other words, you might build this in your data center. I've built lots of these for customers. I can tell you it's very complex and very expensive, but occasionally there are use cases where this is beneficial to a company. So here we have a virtualization cluster. We have storage and backup systems. We've got network and firewall systems. But then on top of that, we have to add on those capabilities. So we need the self-service. We need the service catalog. We need the service automation. We need orchestration, so everything is automated in terms of the delivery of the service. Monitoring and logging, so we know what's going on. Billing and reporting, so that we can charge the customers. Multi-tenancy, so that we can have multiple customers. And if you're within a company building a private cloud, those customers might not be other companies. They could be different companies within a group of companies, or they could just simply be different business units within your company. And then we've got other things like configuration management, lifecycle management, security and identity, and so on. Now, of course, all of this comes with quite a significant cost. We've got the data center itself. You've got the security services. You've got power. You've got connectivity. You've got physical hardware, software licensing, and maintenance contracts. And then, of course, you've got staff costs, lots of operations and management. So building a private cloud is quite an expensive exercise. And often you still don't get the capabilities that you might get from a public provider like AWS. So what is the public cloud? So the public cloud, and of course an example here is Amazon Web Services, but there are others like Microsoft Azure and Google Cloud Platform as well. But it's basically a cloud that is accessible to the public. So you as an individual or your company can come along with a credit card, set up an account and start utilizing those cloud services. Now, if you're a company, you will typically have some kind of office or maybe a data center if you've got your own systems. And you can then connect to that public cloud either just directly over the internet, or you can set up a private connection or a VPN over the internet. And then you can start deploying services like compute, storage, network, and databases in the cloud. And there's many, many more different types of service on AWS. So the benefits of this model: you have a variable expense instead of a capital expense. So you're paying on a monthly basis for what you use. There are exceptions to that. AWS does have some larger discounts if you lock in for a year or 3 years. But other than that, most services are available on a monthly expenditure where you're just paying for what you use. You've got economies of scale. So AWS are huge. They've got hundreds of thousands of customers all over the world. They invest very heavily both in their platforms and in the software that sits on top of it, all of those services that they build. So that provides economies of scale, which means they can reduce the cost of those services to you as the end consumer. And you get massive elasticity. AWS are huge. They have such a massive amount of compute power that it's very rare that they're going to run out. There's usually always some capacity somewhere. And so even the biggest companies with the largest requirements don't have an issue scaling in the cloud. And as I mentioned, other examples would be Microsoft Azure and Google Cloud Platform as well. AWS is by far the leader in this space. Azure come in second place and Google Cloud Platform a little way behind that. Now, there's a few different service models in the cloud. The first one is private cloud. We just had a look at that. That's where you build it yourself. Now, if you build it yourself, not only do you have that big capital expenditure, but of course you have to manage it. All the responsibility is on you. Then we have what we call infrastructure as a service, or IaaS. This is where essentially you have managed virtual machines. So if you understand virtualization, essentially it just means that you have virtual servers running an operating system like Linux or Windows, and everything underneath that operating system is managed for you. Then we've got platform as a service, which is another level up. It means less overhead for you in terms of management. Now you just bring your code. And lastly, software as a service. So here everything is managed for you. You know, going back to salesforce.com or email services like Gmail. That's a SaaS service because everything is managed for you. You have very limited scope though in terms of what you can do to modify the platform. So let's look at these side by side. On the left-hand side here, you've got the private cloud. So here, everything is managed for you. We saw before that there's lots of software layers, which I'm not showing on this screen as well. So you have to manage everything. With infrastructure as a service, you can see here the server layer, including all the associated storage and networking, and the hypervisor are managed for you. So now you have these virtual machines, these VMs just sitting on top. In the cloud, we also call them instances. So what you have to manage if you're using IaaS is the operating system, so Windows or Linux, and you have to manage all the updates, for example, the software updates, then any application frameworks that you're using, and then your data, of course, and then your application itself. If you go to platform as a service, you lose some of that responsibility. So you give it away, you outsource it to someone else. So now all you're doing is bringing your data and your code for your application. Everything underneath it is managed. And then lastly, of course, we have that SaaS service where you basically don't have much responsibility, but also it means you have less control. You're losing control as you give this away, moving from where you have that, larger expense and larger complexity on the private cloud on the left-hand side through to a SaaS service on the right, where you no longer have to worry about a lot of stuff, but of course you have less scope to modify it or customize it to your own requirements. Okay, so let's look at Amazon Web Services, AWS. So they are what's known as a hyperscale public cloud provider. They've got well over 200 services. I don't give exact numbers because it changes all the time. Occasionally they decommission a service, usually with a good bit of notification, usually about a year or so. But mostly it's just about increasing that number because they're constantly adding new services all the time. In terms of market leadership and growth, they are the leading cloud service provider with by far the largest market share. And they have global infrastructure. So that means they've got data centers and infrastructure equipment within those data centers all over the world. And we'll look a bit more into detail on that in a moment. In terms of innovation and expansion, AWS is known for rapid pace of innovation. It's hard to keep up sometimes because they are constantly innovating, changing things, improving them, and releasing new services. So let's have a look at the global infrastructure at a high level. So around the world, AWS has regions, and these are essentially separate physical locations in the world. There are many of them around the world. Again, the number increases all the time, so I'm not going to give you an exact number. So you can see here we've got US East, we've got EU West, and we've got AP Southeast. Now each region consists of multiple availability zones. You can see in the diagram here we have 3 availability zones in each region. Now some regions will have more than that. An availability zone is essentially one or more separate data centers. Okay, so it's at least one separate data center. So for most purposes, I just consider each availability zone to be a data center, but it could be more than one data centers. And AWS don't tell us that. They don't release that level of information. All of these regions are connected with a network known as the AWS Global Network. And that's a highly redundant network with very good bandwidth and low latency. So how do we go and manage AWS services? There's a few different ways. We're going to look at those now. The first one is the management console. This is a graphical user interface accessed via a web browser. And from there, we can find many services. You can see some examples here. On the left-hand side, these are just the categories of service. And then on the right-hand side, we're just seeing a snippet of the ones that start with the letter A. There's obviously a lot of services here. The next option we have, if we don't want to use the graphical user interface, is the command line. With the CLI, we can run simple commands like this one to launch a virtual server in the cloud. Or this one here will list the contents of a storage container that's called a bucket on the Amazon S3 service. The CLI is a utility that you can install on your computer, whether you're on Windows, Linux, or Mac. You can also run CLI commands in the cloud on AWS as well, using a service called AWS Cloud Shell. Lastly, we have programmatic management. Here we're using a software development kit, and there are several different software development kits for different programming languages. For example, we got Boto 3 for Python. So a developer will write code in an integrated development environment, an IDE, or some similar tool, and then you can package that code, and that code is able to speak to the API on AWS. So basically anything that you want to do in the cloud, you can do either through the management console, the command line interface, or if you're a developer, you can leverage one of the software development kits. So you can see we have a huge amount of power here, and we can perform this management using one of these different methods from anywhere in the world over the internet. Okay, so that's it for this lesson. Just a brief overview of cloud computing in AWS, and we're going to get into a lot more detail in subsequent lessons. Welcome back. In this video, I'm going to give you a brief overview of what AWS accounts are, how we create them, and how we manage them. And then in the next lesson, I'm going to show you how to create your own free tier account on AWS. Welcome back. In this video, I'm going to give you a brief overview of what AWS accounts are, how we create them, and how we manage them. And then in the next lesson, I'm going to show you how to create your own free tier account on AWS. So to get started, what do you need to open an AWS account? First thing is you will need a credit card. Secondly, you're going to need a unique email address. And by unique, I mean it cannot be associated with any other AWS account. Now you can create multiple AWS accounts, but you will need a different email address for them. But the credit card can be the same. I often use dynamic email aliases. So if your email address was john@gmail.com, you can do john plus AWS account 1@gmail.com and then AWS account 2@gmail.com and so on. That's a dynamic email alias. It works with Gmail. It works with some other mail services as well. So once you've got these two things, you can create an AWS account. Now when you do so, it's going to create something called the account root user. Now the account root user logs in with the email address that you created the account with. So there's going to be an email address and a password. Now the root user has full control over the account. You also cannot limit most of the permissions associated with the root user. For that reason, it's an all-powerful account and we don't want to use it. The best practice is to set a very strong password and then not use the root user account unless you specifically need to. What we do instead is we use the Identity and Access Management Service, IAM. With IAM, we can create users, groups, roles, and policies. So what we do is we create a user account, we then create a group to put the user into, and then we associate a policy that has permissions to that group. You'll see how to do this in another lesson. That user can have a username like your own name. I use Neil, of course. And so that is the user that you are then going to use subsequently to log into AWS. So it's very important to remember that it is an IAM best practice to create individual users and to avoid using the root account unless you specifically need to, and there are a few cases where the root account is required. So we have our AWS account. We can log in through the management console. That's going to be the easiest way to get started. And from there, what we need to do is authenticate. So when we log in with an IAM principal, like a user account, we essentially have to authenticate. And of course, we have these different methods of accessing AWS and managing it. We can use the console. We can also use the command line interface, or if we're developing code, we can leverage the API through a software development kit. But we always need to authenticate, prove that we are who we say we are. For example, with a username and password if you're logging into the management console. Then we get authorized to access certain resources. And this is defined through policies. The policies define what resources we're allowed to access and what level of access we have. For example, we might have access to EC2 instances, RDS databases, S3 and load balancers. Now, all identities and resources are created within the AWS account. There are ways that you can have multiple account structures where you can centralize some of the management, but each of the users will exist in one place, and then you have to implement measures to access resources across different accounts. So that's it for this lesson. We're going to go ahead in the next lesson and create our free tier account. So make sure you've got a unique email address and a credit card ready. Hey guys, and welcome to this section of the course. In this section, I'm going to teach you about Amazon Web Services. I need you to understand what it is before we can start getting into more of the practical elements and deep diving into the different topics and services around AWS. Hey guys, and welcome to this section of the course. In this section, I'm going to teach you about Amazon Web Services. I need you to understand what it is before we can start getting into more of the practical elements and deep diving into the different topics and services around AWS. So this section is the only section that doesn't have any hands-on lessons. It's pure theory. So just sit back and listen, take some notes, and learn about Amazon Web Services. Hey guys, welcome back. In this lesson, I'm going to cover the AWS Global Infrastructure. That is the name that AWS assign to the various infrastructure, including the data centers and the availability zones and other equipment that they have all over the world. So let's have a look at how it's composed. So firstly, hey guys, welcome back. In this lesson, I'm going to cover the AWS Global Infrastructure. That is the name that AWS assign to the various infrastructure, including the data centers and the availability zones and other equipment that they have all over the world. So let's have a look at how it's composed. So firstly, we have regions. The regions are separate physical locations around the world. Now, there are lots and lots of regions around the world, and the list is growing all the time. Within each of the regions, we have multiple availability zones, usually at least 3. Sometimes there's more than that. For example, US East 1 there has 6 availability zones at the time of this recording. All of those numbers can always change. Now, an availability zone is one or more physical data centers. So just consider it to be a separate data center. Now, that means that you can spread your resources across availability zones, and there's less correlation in terms of failure. So if one data center fails for some reason, then the other one shouldn't. So you can spread your resources and make sure that you always have your applications running when you need them. Now, all of the regions are connected around the world by AWS Global Network. That's a network that's managed by AWS. They make sure that there's plenty of bandwidth and they manage the latency, so you get great performance when you're moving data between AWS regions. Now, within each region as well, there's lots of networking capability that's always redundant. Now, what else is there other than regions? So we have regions and availability zones. Within the availability zones, we create subnets, which can be public or private, and that's where we launch our resources. There's also other ways that you can leverage AWS services. For example, if you have a corporate data center, you can actually get a piece of hardware that comes into your data center. It's called AWS Outposts. And AWS Outpost supports a subset of services available from AWS. So not everything, but things like EC2 can be run on premises. And it has connectivity, of course, back to an AWS region. Next, we have something called a local zone. These are a bit like availability zones, and they're usually in metropolitan areas. And the idea is that they get your resources just a bit closer to where you are. So if there's a local zone that's closer to your office or your data center than the actual region data centers themselves, then that can be a good place to launch your resources. And you pay a bit more for it, but you get lower latency. Then we have wavelength zones. These are for 5G. So if you, for example, have mobile applications and you want to make those available over the 5G network, you can deploy your applications in a wavelength zone. And again, it's about lowering the latency, lowering the delay between the server or the mobile application in this case, and the actual service that's being delivered from the data center. And again, wavelength zones have connectivity back to the AWS region. So they're about performance, about increasing performance for your applications and connecting them to your end users or to the servers in your data center. Now let's break down a region to give you a bit more detail about the level of redundancy here. So here I'm just showing 2 availability zones. There's usually more than that. So each availability zone can then be used to create subnets. Okay, a subnet is just an IP networking space. So you can create public subnets. They have public accessibility. That means your applications like your web servers can be available on the internet, or you can create private subnets that have no direct connectivity from the outside world. Now, each availability zone has redundant power sources, so you're not reliant on one power source there. If one fails, the other one should pick up the load. We also have redundant networking, both within the availability zone and between availability zones. Now, availability zones have low latency between them, so the network performance between availability zones and within them, of course, is very good. And that's because the availability zones are relatively close together. AWS don't specify exactly how close, but they're relatively close within a metropolitan area. On the other hand, the actual regions are fairly distant from each other. So it makes sense to keep your applications, make them highly available within a region so that you've got great performance and you can fail over very quickly between one availability zone and another. However, if for disaster recovery purposes you need to have a copy of your applications more geographically distant, then that's where you would put them into a separate region. So now we can deploy our resources across our different subnets within different availability zones, and that's how we get high availability. And we'll see how we can then connect to them a bit later on. Another component of the AWS global infrastructure is Amazon CloudFront. CloudFront is a content delivery network. What that simply means is that content, for example, videos or images, can be cached at different places around the world. And that means that users in those different places in the world are able to access those resources with lower latency. Again, it's about network performance. It's about the performance of the application. If you want to watch a video from Australia, you don't want that video to be physically located in the US because that's a long way away and the performance won't be good. So CloudFront makes sure that it's cached in different parts of the world so that there should be a copy of that video closer to you. Now, with AWS, we can, of course, very simply deploy services globally. Absolute game changer with the cloud here. In the past, when I used to have to deploy resources into different data centers in different parts of the world, it was extremely difficult. It was also extremely expensive. Now, with the management console, the CLI, or the API, you can deploy resources all over the world. For example, here we're launching virtual servers and databases in different parts of the world. And in some cases, you might set them up to be redundant and automatically copying data between them and synchronizing that data. Very, very easy to set up in the cloud. Very difficult to do it outside of the cloud when you're managing all of that infrastructure yourself. Hey guys, in this lesson, I'm going to cover a concept known as the AWS Shared Responsibility Model. So this is a graphic straight from AWS. This is a very important concept. You need to understand Hey guys, in this lesson, I'm going to cover a concept known as the AWS Shared Responsibility Model. So this is a graphic straight from AWS. This is a very important concept. You need to understand what it is that you are responsible for and what it is that AWS as the provider of cloud services is responsible for. And so you can see that delineation here. Now, on the top there, we've got the customer. That's you as the consumer of the cloud. Of course, at the very, very top there is data. Data is your problem. That's your data. It's your responsibility. Now, of course, underlying all this, for data, we've got storage, we've got databases, we've got connectivity services for transmitting data. AWS are supplying those services, and they supply the options for things like encryption, and they make sure that your data is durably stored and copied into different places. So you need to understand how they do that and what the levels of durability and availability are, but ultimately you're responsible for your data. Now, again, platform applications, identity and access management. AWS provide the identity and access management service, but you're responsible for creating users, creating groups, creating roles, creating policies, assigning the correct permissions. If you provide too many permissions and somebody does something that they shouldn't, then unfortunately that is your responsibility. That does become your problem. Now, underneath that, we've got operating systems. Now, here, in some cases, AWS will manage things like the patches of operating systems. So there are some examples of where that's a shared responsibility. But mainly, for example, if you're using the Amazon EC2 service, then the Windows or the Linux updates are something that you have to manage. Again, network and firewall configuration there. So AWS will provide the features for the networking capabilities like security groups, which are firewalls for EC2, network access control lists, and they give you the ability to encrypt your communications as well. But you ultimately have to utilize those resources and those features to make sure that your data is properly protected. So the three boxes in the middle here in blue, it's all about encryption and protecting your data at rest and in transit. All your responsibility. Underlying all this, of course, we have AWS, and AWS will provide the regions, the availability zones, the edge locations. Those are the ones for Amazon CloudFront. And they're going to manage all that global infrastructure, including the security of it. And then the various services on top of that. So you've got the infrastructure layer, compute, storage, database, networking, and more, and then all the software on top of that. So they are obviously responsible for that. They say that they are responsible for security of the cloud, and you're responsible for security in the cloud. So just to show you this in a slightly different graphic, here you can see the customer responsibility on the top and the AWS responsibility on the bottom. So things like managing the data in your buckets, that's up to you, as is creating things like roles, setting up multi-factor authentication, configuring security groups and network access control lists. This is all a customer responsibility, along with things like patch management. And then underlying that, we've got the actual database servers, disk drives, physical network switches and routers, and the software layers, the control planes that sit on top of them. And of course, the data center security, that's no longer something you have to worry about. So that's the AWS shared responsibility model. There's much more information on this on the AWS website. It is important to understand this split of responsibilities so that you know what you're responsible for and what AWS will be providing. Hey guys, and welcome to this video. In this video, I'm going to teach you about application programming interfaces, or APIs. Now this can be quite a confusing subject. I think it was quite a few years before I really fully understood what they were from when I first started hearing about them. And it was never really explained to me that well. But APIs are integral to the cloud, so they're a really important concept. Now let's start off by talking about ports and protocols, just for a bit of basis here. So if we're using a computer to connect to Amazon.com, so the website Amazon.com, we're going to be using a browser. Web browsers use a protocol, that is HTTP. Hey guys, and welcome to this video. In this video, I'm going to teach you about application programming interfaces, or APIs. Now this can be quite a confusing subject. I think it was quite a few years before I really fully understood what they were from when I first started hearing about them. And it was never really explained to me that well. But APIs are integral to the cloud, so they're a really important concept. Now let's start off by talking about ports and protocols, just for a bit of basis here. So if we're using a computer to connect to Amazon.com, so the website Amazon.com, we're going to be using a browser. Web browsers use a protocol, that is HTTP, the Hypertext Transfer Protocol, or HTTPS, which is the secure version with encryption. Now, the protocol is essentially the language that's used for communication over a network. So HTTP is used over the internet. It's a really great protocol for the internet. It's very reliable across the internet, which can have varying performance. Now, on the Amazon side, there's something called a port. And the port is going to listen for incoming connections. So I often refer to it as a door behind which a service is running. So there's lots of different doors with different numbers on them, just like in the hotel. And behind each of those doors is a service. So in this case, there's a web service. And web services run on port 80 for HTTP and port 443 for HTTPS when we have encrypted connections. So these are common ports. Now the HTTP protocol has something called methods. They're sometimes known as verbs as well. We have the get method. This is retrieving information. So when you're connecting with your browser to Amazon.com, your computer needs to download some pictures and some text, maybe videos, and display that information onto your computer. So it's performing a GET request. Your browser is submitting a GET request to Amazon.com. Now, if you're uploading data, you're going to be using POST or PUT. So the POST is the method used to submit data, to upload something, and then if something needs to be subsequently replaced, then we're using the PUT method. And then there's the delete method as well for deleting data. There's more than that, but those are just a few to give you an idea of what the HTTP methods are. So coming back to our example of Amazon.com, the computer is submitting an HTTP GET request to the web server, and the web server is then returning the content to the client. Okay, so why am I talking about ports and protocols and HTTP? The reason is with APIs, we're actually leveraging these common protocols. So an API, it stands for Application Programming Interface, and it's essentially a set of rules and protocols that allow computer programs to talk to each other, just like a web browser talking to a web server. The APIs assist with sharing information and data between those programs, and they leverage standard protocols like HTTP. So when we're leveraging the cloud, we're actually able to speak to Amazon, or AWS in this case, using HTTP via an API. AWS have APIs, and those APIs define the actions that you can request on AWS. So it's almost like a menu in a restaurant, and you can choose what you want. So what action do you want to perform on AWS? Maybe I want to launch a web server. Maybe I want to delete something. Maybe I want to create a database, or maybe I want to create a new user. Now the computer here, which is on the internet, is able to use the AWS Management Console in order to perform actions on AWS. Even when you're using the Management Console, everything is resulting in an API call to AWS. So it doesn't matter whether you're using the Management Console, the visual interface, the command line interface, or if you're a developer writing code using an SDK, you're always speaking to the AWS API. So maybe here somebody wants to create a new user account. So they do so through the visual interface of the Management Console, but on the back end, what's actually happening kind of behind the scenes, if you like, is an API call is being made to AWS. And it's going to use that language of the internet, HTTP, to speak to the API. So that means we're able to leverage the common language of the internet. We're able to leverage HTTP and the get, put, post, etc. methods in order to perform actions on AWS. So it's a really great method of leveraging the internet and those standard protocols and web browsers in order to manage the cloud. And in this case, a user has now been created on AWS. So every single action that you take on AWS is actually an API call. Again, whether you're creating databases or deleting Amazon S3 buckets or updating a virtual server on EC2, everything is an API call. Let's have a look at some more examples. So with Amazon S3, we have the get object API action. So you can imagine this is actually going to result in an HTTP GET request, and that is to retrieve objects from Amazon S3. In other words, download a file from S3. It's just a storage service, basically. So here we have the API for S3, and through the Management Console, we're issuing an HTTP GET. In AWS language, that's an S3 GET object request. And in response, an image is downloaded to the computer. We could also upload objects to the bucket. So here we're going to issue the put object API call. We have a PDF on the computer, and we're able to issue the put object, and that PDF file is then uploaded to S3. So essentially, every action that we want to perform on AWS is going to be an API call, and we're leveraging this protocol of the internet, HTTP, in order to make those requests. I'll give you another example that you may be familiar with. Here we have a flight aggregator service. So this could be something like Skyscanner, Momondo, there are many others. So here you might want to fly from, let's say, New York to Dallas. So you put in your source, your destination, the time and date that you want to fly, and what they'll do is they'll actually go out to the various airlines and find out which flights might suit your needs. So we're searching for flights, and what they're able to actually do here is talk to an API. So each of the airlines will have an API, which means that the flight aggregator essentially just issues a request that says, this is the information that we want to find a flight that fits this criteria. And then the API will return the results, and you as a purchaser can then choose which flight makes sense for you. So that's APIs. It's a concept that's super important for the cloud because, as I've mentioned a couple of times, everything in AWS is an API call. So every time you're changing something, an API call is being made.